Here we have some diagrams of a pump package and some of the accessories that go along with this pump package. You can see that it's a basic pump package up in the upper left-hand corner. But as you look at it, we've got 8 diagrams here that I'm going to go through total. If we take a look at the first one here, it's the motor itself, the pump and the motor. This is the setup that you saw in the video, and this is just going to explain it a little further. You can see that we have right here, we have water in. That's going into the package. We've got a valve here that it's a plastic ball valve that is used to shut the water supply off if you really want. We've got the motor and the pump, and that's a diaphragm pump. And then out of the pump, we've got a T or an elbow here. Then we've got this water regulating valve there. And then we've got kind of a drain primer valve there. And we've got a gauge here. And then in here, it's not diagrammed here, but there's a check valve in there. So this is the discharge. It comes out of here, goes here, and then when pressure builds up, this regulating valve here that I pointed out before, there it is. It regulates the pressure at this point, and some of the water goes back this way, back into the inlet. Now, what happens is that you can set that through this screw mechanism here, and generally it's set at 150, 160, 170 psi. So water goes out here, high pressure. This regulates it at 150 psi, and then it goes out here to the output. So that's that's how that works. All right. Now, if we look at the next well, let's just include here. Here's the electrical, and then here's outlet. Water out. Now, if we look at the next picture here, what we've got is the same pump package, but then we've got some basic controls that 24 volt our 24-hour timer right here, 7 days a week, and then a cycle timer to cycle the pump on for 10 seconds, off for 30 seconds, whatever we want. And then this variac here controls the speed of this motor. So what we have is we can slow that motor down to make it last a little bit longer. So it's kind of that. Now if we take a look at the next picture here, here's really how it would get put together. Here's the pump and the motor, and then this is a control panel. These are 12 by 12 by 4 inch panels, 4 inches deep, 12 inches wide, 12 inches wide. Probably what would happen is you'd bolt those together like that, and if you needed to run any control wires, you could, or power wires, you could run it between cabinet and cabinet. So that kind of shows how it might go together. The next picture here is the pressure regulating. We're getting into the regulating section. This is out at the duct section itself. This is one option that shows a pressure regulator that regulates the pressure out to the nozzle. Actually, what it's doing is it's acting as a check valve to a degree. So 170 degree psi water goes through there, and then when it goes, the gauge goes up. Pressure goes up on the gauge. And this guy, this unit might be set at 120 or 130 psi. So as soon as this aerator here reaches 120 or 130 psi, it lets water through to the nozzle. And then when the pump happens to shut off, where we don't have any flow here anymore, water will go through here until the nozzle gets down to 120 psi, let's say, and then the spring pressure shuts off here, and no more fluid goes through. And so now we've got, right at this point and all the way back to the pump, we've got 130 psi water that's trapped in there. Now this nozzle has a little check valve in it. It might go down to 40 or 50 or 60 psi. So we've got this trappage of water here, and what that does is as soon as this thing shuts off, the nozzle kind of shuts off itself, and it eliminates dripping and spitting because we've only got this one little line right here to left. There's just not much volume in that line, so it shuts off right away. So that's how that works. Now if you take a look at this next picture, what I've added here is a wall plate. So this would attach onto the wall, or the side of the duct, and so that's that plate that has a cushion clamp right here, a threaded rod in the middle here, and then there's two screw holes right here that would attach onto it. So that's kind of what that would look like. If you take a look at the next picture here, this is kind of how it will be set up. I mean, we've got a wall duct here this is the wall, the duct, and its wall, and then here's the plate with the cushion clamp and the threaded rod here, and that's holding this assembly onto the wall, and then here's the pressure regulator, so supply goes that way, goes through here, and it goes to the duct. So that's kind of how that would work. I kind of like that setup. Now the next one, I gotta be quick here. Here's the solenoid one. This is doing the same thing, except for we got a solenoid and a pressure switch. Here's a gauge here. Here's a pressure switch. Again, this is set at about 120 psi, and as soon as the pressure comes this way, this pressure switch turns on and causes power to go to this solenoid valve, opening the solenoid valve and going out to the nozzle. So the same kind of thing. And this pressure switch could have a cycle timer on it. That's these little devices right there that would cycle the pressure on and off. So that's then you got the duct here, and I'll show you that in the next picture here, where here's it kind of set up on a duct. You got a duct wall here, and then here you've got two threaded rods with some wall plates and cushion clamps, just because it's a little larger assembly. The same thing, pressure switch. You've got power coming in. It could be 24 volts, 100, 240 volts. Power comes into the pressure switch, goes to the, as soon as it gets to 120 or so, goes to the solenoid, opens up the solenoid, and we get power to the nozzle. So that's how that would work. I kind of like that setup too. It's a little more expensive, but you get positive shutoff here at the solenoid, where you kind of get some weeping with the regulating switch. So